Okay, good morning. Today in statistics, we're going to talk about section 8.5, testing claims about a population mean. Remember, our symbol for population mean is mu. And I know what you're thinking. You're thinking, well, didn't in 8.4, didn't we just talk about testing claims about mu? And yes, we did. But remember, the provision was in section 8.4 that sigma was known, and we're going to expand on that in 8.5 and say, well, what if, perhaps more realistically, if sigma is not known? What do we do then? Okay. All right. Again, the framework is going to be largely similar to what we've done in 8.3 and 8.4. Basically, we've got a large population with perhaps millions of numbers, millions of measurements, and we seek to estimate the population mean, which typically we never know. And to do that, we are going to first grab a sample and compute the sample mean. So what we're going to do is use sample mean to test claims about population mean. In 8.4, we used z-scores of the sample mean to test these claims, but in section 8.5, we're going to use a t-score. We'll hopefully bring something in chapter 7 to remembrance, as in section 7.4. Hang on, that didn't come out very well. Try that again. Just as in section 7.4, if sigma is unknown, which is more realistic, remember you need the population mean to compute the population standard deviation. So perhaps it's more realistic to claim sigma is unknown. We will use S, your sample standard deviation, instead of your population standard deviation in computing the t-score in this section of your sample data. Alright, so we're going to use S instead of sigma, and we will use the t distribution instead of z to compute ultimately the p-value of your sample data. Remember, your p-value will pretty much tell it all in any form of hypothesis test. Alright, framework is the same as we've seen in section 8.3 and 8.4. Step 1 is to state hypotheses. We beat on that pretty good. Number 2, compute the p-value. And as you might expect, we are going to introduce another test, another operator under the tests submenu of your TI-8384 calculator to do this. And step 3 is compare your p-value to your alpha level, and then perhaps an interpretive statement to finalize the problem. Alright, so the framework is largely the same as what we've done in the last two sections. Basically, we're going to be introducing a new command under the tests submenu. Alright, let me talk a little bit more about that. Recall, in section 8.4, we use the z-score of your sample mean to compute the p-value of your sample mean. Basically, it was according to this formula. Now, I know the calculator does this upstream. We did it by hand once. Just to show you where we've come from. Alright, so this is the z-score of your sample mean, and of course, as you recall, the z-score of your sample mean determines the p-value of your sample data. So this z-score will be demarcated here somewhere. If we're talking about a z distribution, well, this z-score of your sample data will cut off a tail area, and this tail area is called the p-value. As we said in class, that small p-values, small tail areas mean your sample data is extreme and you reject H0. And if p-value is relatively large, then you fail to reject. Alright, in section 8.5, we're going to largely do the same thing. But instead of a z-score, we're going to use a t-score. Use t-score of your sample mean. All right. Now I want to talk about, we've talked about the t-score or t-distribution earlier in chapter 7. Let's refresh our memory here. The t-distribution. Well, it looks a lot like the z if you were going to graph one on top of the other, but has a greater standard deviation. T-distribution allows for the greater spread or variance seen in small sample sizes or when sigma is unknown. Again, that introduces, when sigma is unknown, that will introduce greater uncertainty into your problem. And remember, we are assuming sigma is unknown in this section 8.5. So when sigma is unknown, largely we will use the t-distribution and hence t-score to compute the p-value. All right, the formula for t-score is this. Now again, the calculator computes this upstream, but I want to show you where it comes from. Notice it's identical to the z-score formula, except instead of sigma, which here is unknown, we're going to be using S. Your sample SD will replace sigma in that z-score formula. Okay, and the emotions of it are largely the same. And remember, the t-distribution is bell-shaped, it's symmetric, it has a mean of 0. Much like the z-distribution, it's got a greater variance, greater spread. Well, your t-score of your sample data, if I mark it off on the t-axis somewhere, your t-score of your sample data will define a tail area, and that's what I call the p-value here as well. So we can see if your p-value is small, your sample data is extreme, and that implies we reject H0. Okay, let me write that down. If your p-value is small, that means the t-score of sample data, here it's a sample mean, is extreme, and that implies we reject H0. Okay? Alright. In wide strokes, in, not if, in, hang on. In testing hypotheses, if sigma is known, and we're going to be testing hypotheses about mu, and if sigma is known, well, we know to use the z-test command on our calculator, right? Our conclusions will be based on the z-score of your sample data. And if sigma is unknown, if we go to our stats mode and test submenu, we'll see number 2 on that menu is the t-test, and that's the one we're going to use in section 8.5. We use the t-test if sigma is unknown. And as we'll see, the calculator automatically substitutes S for sigma in the concerned formulas. Alright, let me get a fresh screen here. I'm going to start an example. And I want to cite example 1 on page 434. Now let me warn you, the author does not use the p-value approach that we are going to use here, so it may not quite look exactly like the author's solution here. Alright, let me read the problem. Example 1 on page 434. We're going to use the p-value approach. Basically, the author assumes that you don't have the TI 83 or 84 calculator, and we of course do. Makes it quite a bit easier, as we'll see. Example 1. Overloading boats. Again, we're using p-value method, not the traditional method, right? We're going to use the same given information. In example 1 of the preceding section, we noted that people have died in boat accidents because an obsolete estimate of the mean weight of men was used. Using the weights of simple random sample of men from dataset 1 and appendix B, we obtain these sample statistics. Alright. So, we have a sample size of 40. The mean weight from the sample of 40 is 172.55 in pounds. S, the sample standard deviation. Alright, now notice there's no neon sign that lights up and says this is not the population SD. You have to extrapolate that from the given information. Alright, next sentence. Do not assume that the value of sigma is known. Alright, there. I suppose you could call that a neon sign saying that sigma is not known. Use these results to test the claim that men have a mean weight greater than 166.3. Mean weight greater than 166.3. Alright, so what we're going to do is put this claim to the test. If mu is greater than 166.3 is the claim we're given, we're going to label that H1. As usual, this is going to be a right-tailed test. And that means H0, the null claim, the null hypothesis, is the corresponding equality. Okay? Alright, so step 1 is done. We've stated the hypotheses in the usual order. Right? Again, don't lose sight of what we're doing here ultimately. Someone has made this claim by implication, and someone is challenging this claim with this sample data information. Now, certainly 172.55 looks quite a bit bigger than 166.3. The idea here is it significantly bigger? Is it significant enough to reject the null claim? And of course, we'll make our decision based on a p-value. Alright, so step 1 is done. Step 2, compute the p-value. Oh, I forgot to put the alpha level. Let me put the alpha level here before I go on. Use a 0.05 significance level. Seems like the book is kind of stuck on that 0.05 significance level. I suppose that's pretty much the most common moderate level of significance in any hypothesis test. Alright, p-value. Again, we're going to be introducing a new command here. Click on stat. Then, of course, tests, just like in 8.3, just like in 8.4. But now in 8.5, because sigma is unknown, we're going to pick the option t-test. It's number 2 on that tests submenu. Alright, for input mode. Well, of course, we're given summary statistics, so for this problem we're going to use the stats input mode. Mu sub 0, remember that's the TI code for H sub 0 equals the sample mean. Well, that's given to us as 172.55. S cap SX, remember that's the TI code for sample standard deviation. And remember, because population SD is unknown, we are going to use our sample SD. And the TI calculator recognizes it, so it labels it as cap SX instead of sigma. Little n is 40. And we've got to pick the type of test. Alright, so mu, again, this is a right tail test, so we'll pick mu greater than mu sub 0. Select, or highlight and select. And then, of course, calculate, highlight, and select. And my results screen is going to look like this. Well, the first line of code in the printout is the alternative hypothesis, just to remind you. It gives us then a z-score. I'm sorry, a t-score, not a z-score. Because we are basing our decision on a t-score of the sample mean. And here's the money ball right here. The p-value here is 0.0706, we'll call it, in change. And the calculator reminds you of the mean, the standard deviation, the sample size. But again, the p-value is really what we're looking for in this output screen. Alright, so then I'm ready for step 3 to compare the p-value to your alpha level. The p-value is 0.0706. Remember, the alpha level was 0.05, and clearly this is bigger than alpha. Right? And large p-values suggest H0 is true. Remember, if your p-value is greater than alpha, your evidence is weak, and I fail to reject H0. So that's my final conclusion for this problem. I could add an interpretive statement. I'll say a sample mean of 172.55 in pounds is not significant, or I could say it this way, is not extreme enough, or in a right tail test big enough to warrant rejection or rejecting H0. All right, let me scroll up to the original problem statement, because I suspected in the beginning that this would be significant with respect to this claim. Well, I guess you never really know until you grind it out. There's other things in influencing this p-value, such as sample size and, of course, the sample standard deviation. So at first glance it might seem like a significant difference, but in the end it wasn't significant enough. We failed to reject H0. Alright, so that's a right tail test. I want to go through two other tests in this class. Of course, a left tail test and then a two tail test. Next one I want to look at is number 15 on page 440. I believe this is in your homework list. Let me turn there myself and read the problem. Alright, cigarette tar. A simple random sample of 25 filtered cigarettes is obtained, and the tar content of each cigarette is measured. The sample has a mean of 13.2 milligrams and a standard deviation of 3.7 milligrams. Use a 0.05 significance level to test the claim that the mean tar content is less than 21.1. Mean tar content is less than 21.1. Alright, so of course this is going to be my alternative hypothesis. My null hypothesis will be the corresponding equality, and of course I'm going to label this as a left tail test. Let me write down the given information. The sample mean was 13.2 in milligrams of tar. The sample standard deviation was 3.7. The sample size was 25. And the author wants us to use a significance level of 0.05. Alright, so step 1 is done. We've stated the hypotheses. Step 2, p-value. And again, of course, we're going to use the p-value approach here. Hit stat on your calculator, tests, then the t-test operator because sigma is unknown, right? Alright, so sometimes that's implied in the problem statement. And if sigma is unknown, we will use the t-test. Alright, so I'm not sure if I have to write all this down. We've done this command similar to this enough. And your input mode will be stats because we were given summary statistics. Mu sub 0, 21.1, sample mean 13.2, sample standard deviation was 3.7, sigma is unknown, little n was 25. We are in a left tail test, so mu less than mu sub 0, and then calculate, and the result gives me a p-value of 6.75 e minus 11. Alright, now we've talked about scientific notation many times. Let me write this out here. P-value is 6.75 e minus 11. Alright, that's Texas Instruments code for 6.75 times 10 to the minus 11th power. And really that's a decimal point and 10 followed by 10 zeros. And a 675. And I see something this small. I don't want to write out 12 decimal places of accuracy. I'm just going to call this 0 plus. Essentially, your p-value is 0 or approximately 0 for all intents and purposes. Alright, so there's my p-value, and step 2 is done. Step 3, we compare. Well, remember, small p-values suggest h0 is false, and you can't get much smaller than 0 in terms of a p-value. So if your p-value is essentially 0, it kind of really doesn't matter what your alpha level is. I would probably reject h0 here at any reasonable choice of significance level. So my final conclusion is to reject h0 and really at any reasonable significance level. Okay? Alright, so let me interpret this statement here. In this problem, the p-value is so small, and by implication, and the sample, let me write this, and by implication, the sample mean is so extreme, and in this case extreme small because it's a left tail test, that we would reject h0 at any reasonable choice of significance level. Okay? In other words, there is strong evidence, and perhaps very strong evidence, that h0 is wrong, that the null hypothesis, the null assumption, is wrong. Alright, so there's a suitable interpretive statement for that problem. Okay? Alright, one more. We did a right tail test, a right tail t-test. We did a left tail t-test. And now, of course, I want to do a two-tail t-test. Get a fresh screen. Alright, this one is number 27 on page 441 in our text. So let's turn there and familiarize ourselves with this problem. It talks about car crash costs. The Insurance Institute for Highway Safety conducted tests with crashes of new cars traveling at 6 miles per hour. The total cost of the damage was found. Results are listed below for a simple random sample of the tested cars. Use a 0.05 significance level to test the claim that when tested under the same conditions, the damage costs for population of cars has a mean of 5,000. The damage costs have a mean of 5,000. Alright, so that's going to correspond to H sub 0. And if H0 is given as an equality, we are going to assume that H1 is then an inequality statement, specifically that mu is not equal to 5,000. Alright, so it's going to be a two-tailed test. And step 1 is done. Now notice, they don't give us X bar in the problem statement. They don't give us S. They don't give us sigma even. Well, they do give us raw data in the form of 1, 2, 3, 4, 5 different repair costs. So we are going to use our data input mode. And of course, to do that, as in section 8.3 and section 8.4, you've got to clear out L1 and enter in your new data into L1. So to do that, we will go to Stat on our calculators, Edit, and please clear L1 and enter in this new data from problem 27 on page 441, or actually it's on page 442, overleaf. Alright, once you've got that done, we are ready to then go after the p-value in data mode. Alright, so step 2, p-value. Hit Stat, Tests, and of course t-test command, because sigma is unknown. Let me write that down again. Sigma is unknown. They just don't give it to us in the problem statement. Alright, so remember, in your input mode, you're going to want to use data, highlight and select data, alright, it prompts you for the mean, the null hypothesis, the sample mean, the sample SD, the sample size, etc. Alright, we've done this in this. I'm going to go right to the p-value here. So as computed, the p-value, the calculator gives me a p-value of 0.1766. Step 3, we're ready to compare. Your excuse me, your p-value and your alpha level. Your p-value is 0.1766. Your alpha level stated in the problem is given to us to use as 0.05, and of course 0.1766 is greater than 0.05. So my conclusion is to fail, to reject H0. Large p-values suggest that H0 is true. How large? Larger than alpha, right? So I might end with an interpretive statement like this. Excuse me. Not sufficient evidence to reject the claim. What claim? Well, H0, the claim that the population mean for car repair costs as stated is $5,000. Alright, so we've done a left tail test, a left tail t-test, a right tail t-test, and a two-tail t-test, and we've done them both in statistical summary mode and in data input mode. So we'll call it a day as we approach the 30-minute mark, and this concludes this online class.